It's my privilege to be here this evening to speak on this topic that you see on the screen, our privileged planet. We do live in a very privileged place. I'm going to be covering some why we're privileged is design. Design is a big issue for creation versus evolution. And we had the privilege of having Chris actually speak at our forum up in Arlington just last Friday night. And we had a great turnout, a lot of interest in the topic. His topic there was amazing animal designs. And that, of course, raised the question, well, who is that designer? Who designed those animals? Who designed their environment? And as I go through this topic here of our privileged planet, I'm going to also reference a lot of design. How do we recognize design? And what do we do with that? So let me just go ahead here. I give you one key verse here in Isaiah 45:18, which reads, who formed the earth, and that's referring to our Lord God, who formed the earth and made it. He established it. He did not create it empty. He formed it to be inhabited. So earth, as you see by the word, was designed to be inhabited. And we'll see why as we go through this. So I'm going to cover these 8 topics this evening. First of all, I want to make sure we understand what we mean by chance, law, or necessity, and design, those 3 things. And then how do we tell if something is designed? We're going to look at, Earth is a planet going around our sun in the solar system. Why are we unique in where we're situated? We're going to talk about the laws of science in the Bible, talk about mathematical probability, because probability has a lot to do with evolution, obviously. Random mutations and probabilities, etc. And then I want to talk about the anthropic principle. And we're going to look at some of the key physical constants, what their values are, not just for the Earth, but also for the whole universe and for the physics of the universe. What are these constants and why are they so important? And then at the end, I'm going to talk a little bit about searching for other planets. Scientists around the world are using more and more powerful telescopes to look for other planets, not just in our solar system, obviously, because we can see all the ones that we need to see, but also within our galaxy and within the super galaxies in the world, in the universe. And then we'll come to the conclusion how Earth really is privileged and why we're privileged to live on that. So just addressing these concepts. I think you've all seen this picture before, and I want to use that, and a lot of people use this to distinguish between random events and design. Because if you look at the face of those 4 presidents on the rocks there, I think you'll agree with me and say that those faces didn't just appear by chance. It's not because of the angle of the rain that fell on the rock that it just happened to cut out those 4 faces. If I told you that, I don't think you'd believe me. Hopefully you won't believe me. Second is there a physical law that requires those faces to be like that because of how those rocks were situated and a specific angle of the rain or what have you, and it had to happen that way. There's a law that makes it happen that way all the time. I don't think you believe that either. So the only other explanation is, when you see that, is that somebody designed those faces and a sculpture, cut the rock out. So there's design involved. There's intelligence involved in getting those rocks carved out like that. And so every concept you can think of can be explained by one of those 3 ideas. If I look at one of these chairs down here, I think even though it's very simple compared to a human cell, you'll agree it didn't just happen to come, fall out of the roof and just formed a chair just like that. It just by chance. And so it didn't happen by chance. It didn't happen because there's a law of nature that requires it to come because you got this material. and if you put it in the room, it's just going to form a chair. Not going to happen. Somebody designed the chair, and a craftsman built that chair. And that's a very universal concept that we can all agree on. So then just a little bit about origins. It's the whole creation versus evolution debate. How did we get here? Did we get here according to what the Bible says, particularly in the book of Genesis, and other verses as well cover this, but mainly the book of Genesis, we see God created the universe and all life according to its kinds. It's very clear in the first chapter of Genesis, just by the verse, that he created everything. And then 10 times within that chapter, he says he created everything, every living creature, every plant, according to its kind. And he says that 10 times. You think he means that? I think so. And kinds reproduce after themselves. They don't go from one kind to another kind. And then the other explanation is, evolution. And by evolution, we have to be careful how we define that word. By evolution here, I mean macroevolution or Darwinian evolution. Not just changes. I mean, every change isn't, that's not the evolution we're talking about. Molecules to man, or some people like to say, goo to you through the zoo. And, other explanations. But it's a Darwinian evolution that we're talking about. It involves mutations, natural selection, and common descent. In other words, every living being, every living plant came from one living cell, common descent. And then there's intelligent design. And I show again that picture of Mount Rushmore. That pattern indicates that there's some design behind it. It just doesn't happen by chance. And then we have the concepts of irreducible complexity and specified complexity, which I'll define in a minute. If you see those three things, you're talking about design. There's design involved. The only difference between living material and dead material is one thing, and that's information. And today we know that that information is in our DNA. Just not the information, but it's also the programs that work on that information. Okay, that's all part of the design, intelligent design. So how do we tell if something is designed? Well, the first concept is irreducible complexity. You've probably all seen this mousetrap before. A mousetrap consists of 5 identifiable pieces. Some will say, no, you need a 6th one. You need some cheese too, or else you won't catch any mice. But anyway, the mechanical parts of it are these 5 things, which I show here. And if I removed any one of those 5, that trap would not catch any mice at all, whether there's cheese or not. It just wouldn't work. You need all 5 parts. And more so when you look at some of the molecular machines within our body. Okay, if all the pieces weren't there at the same time, you wouldn't have a working bacteria flagellum, in this case, one of the molecular motors. All the pieces have to be there. So in other words, you can't reduce it by just taking one of those pieces out, because it wouldn't work. Then the second part, second way you tell that something is designed, is you have specified complexity. You look at the cell there at the bottom right-hand corner. It's awfully complex. In fact, you could not put that together by random events at all. It just cannot be explained by random mutations and natural selection. So you have the workings of the cell. You have the information that comprises life. You need information for life, the DNA. All those things have to be there. And if you talk about one protein, every working protein has to have certain specific amino acids in a specific order. Let's take 200 amino acids in a working protein. If you take one of those amino acids out, it doesn't work. It has to be in a specified order. So those are two ways you can tell if something was designed. And so we have the inference of design, and this is put together by a mathematician. He came up with a design inference filter. And essentially, our experience tells us that all man-made information systems and complex machines have an intelligent origin. I mean, you look at any machine, a car engine, or even a simple machine, there's no way it just happened by chance. Somebody designed that engine. There's a designer behind it. And the same thing with information in our DNA, in our cell. If we see the complexity of the cell and the order in the cell, we think there's a designer behind it. It cannot be explained by random mutation and natural selection. So, so for living material, we can look at the biological information, and scientists know a lot about the DNA now. Atheists who used to say, well, most of the DNA is just junk DNA left over from evolution, they now know that's not true. All of the DNA serves a purpose, and it has information associated with it as switches, on and off switches and all that. It exhibits irreducible complexity. In other words, if some of the pieces were missing, it wouldn't work. And then there's specified complexity, and that is there are programs built into the cell, into the DNA, that cause things to happen in order and on time. And I always want to give the simple example of the fact that we're created from come from a single living cell. Okay, in the womb, that one cell multiplies to 2 cells, identical cells, 4 cells, 8 cells, 16, 32, and on, all identical. But then all of a sudden, some of those cells change into different kinds of cell. You know, the human body has about 200 different types of cells: skin cells, bone cells, eye cells, fingernail cells, you know, what have you. When do those identical cells start changing and differentiating? If they did that at the wrong time, you know, we wouldn't be here. We'd be just some random mishmash of cell material. It wouldn't work. They are programmed to divide and differentiate at exactly the right time. And that's why we have reproduction working in living material. And then I give these examples here. If I give you these 4 examples, you look at the top left here, scratches on a cave wall. And, you know, for those of you that can see that, the scratches, well, maybe some rocks fell down and they left some scratches on the wall, and that's kind of random. Well, okay, but if there seems to be a pattern there, then you'll agree that's not a pattern. So if you look down the one below, you see the skeletons of horse heads and other animals there. I think you'll agree with me that those characters didn't appear on that wall by chance. Somebody carved them into the stone there, or painted them, or what have you. And so everybody would agree, even atheists would agree, that somebody did that. There's some design involved there. But then you look on the right, and then human genome, where you have 3 billion base pairs built into the human genome, and they want to tell you that happened randomly through evolution. Random mutations and natural selection, that got us there. Now, if the scratches on the left are agreed to be designed, certainly you can say, well, the human genome couldn't just happen by chance like that either. And if you look at the complexity of the cell itself, even one cell cannot happen by chance through random mutations. You know, how do you get that whole thing started? And how do you reproduce? And you each have about 75 trillion of these cells in your body. Tell me how that happens by chance. It doesn't. So how do evolutionists answer that? Well, I just have 3 quotes here. Todd, who is a professor at Kansas State University, says, even if all the data point to an intelligent designer, such a hypothesis is excluded from science because it is not naturalistic. So they won't consider it because it's not natural. Dawkins, biology is a study of complicated things that have the appearance of having been designed for a purpose. Appear to be designed for a purpose. Well, they are designed for a purpose, more than appear. And then even Francis Crick, the co-discoverer of DNA, who you would think would know better, it says, biologists must constantly keep in mind that what they see was not designed, but rather evolved. Explain that one to me. Okay, now let's move on to the Earth's location in space. And, we are one of 8 recognized planets revolving around the sun. And we happen to be the 3rd one in from the sun, and we happen to be located at a temperature because of the distance that is livable by human beings and by other living organizations. The first 4 there, from Mercury to Mars, are all what we call terrestrial cells. In other words, solid planets with solid surfaces that we can walk on. And then you have the gaseous planets, which are further out and in turn much bigger: Jupiter, Saturn, Uranus, and Neptune, and those 8 planets. So we are located on a planet that can support life, obviously. Why can't these other planets support life? Okay, because the temperature is not right, and there's some other things that are not quite right, and we're going to get into that. So, and we are part of the the solar system, but our solar system is one of the star systems in the Milky Way galaxy. And I'm just going to show you a few pictures of that. One thing you'll note, that most of these galaxies are spiral galaxies. They're flat and they're spiral, and they have you can see the lines in there, which is very important. And here's our Milky Way galaxy. This is where we live. The sun is not at the center. It's out towards the edges, and it happens to be about in the middle of those 2 arms, those spherical arms. So it is in a spot where the material is not that dense. It's not in the middle of one of those arms. So we can see further because it is in between those arms. And so there have been other planets found within the Milky Way galaxy, and we'll cover that toward the end a bit. And scientists are now able to identify some other planets in other galaxies as well, although it is very difficult. So most of the planets found to date lie within about 300 light years from our sun. So, within this galaxy here. Next, I want to cover laws of science in the Bible. People often would say that the Bible doesn't contain any science. Well, I wouldn't give the Bible to our children in 1st grade and learn science from it, but there are scientific statements made in the Bible, and we have to ask the question, if the Bible is God's Word and He is the creator of this world, then His world must agree with His Word. And so it's often referred as to the 2 revelations, the special revelation, which is the Bible itself, and then the general revelation, which is nature that He created. So if you look at scientific statements, you'll see in the Bible, there are, particularly in the book of Job, there are, I think, 60 or more scientific statements in the last 4 chapters of Job. And there's a number of them in Genesis and throughout the rest of the Bible too. And so looking at chapter 1, the law of biogenesis, which scientists know to be true now, life comes only from life. Scientists have not been able to create life from non-living material because, the information is not in that non-living material. Some scientists today would say, well, we produced life. No, what you did is you took some DNA and, changed the nucleus of some cells and stuff like that. And, yeah, there's some differences in that life. But you didn't create that life. Life can only come from life itself. And that's very clear in the 1st chapter of Genesis. I mentioned that God mentions 10 times that everything was created according to its kind, and they reproduced after its kind. And so scientists have shown today very clearly that you cannot produce life from non-living material. basically because you don't have the information to do that. The first law of thermodynamics, which states that the conservation of mass and energy, well, in the book of Genesis, chapter 1, actually in the beginning of chapter 2, says God finished all his creation and it was very good, and that's it. Everything was created. The energy that is in the universe has been created, and now we know, scientists know, Moses didn't know that when he penned the book of Genesis, but scientists now know that energy mass is constant. They can change one into another, as Einstein's equation says, but nevertheless, it's constant. Second law of thermodynamics, the law of entropy. In other words, the useful energy in the world is being reduced all the time through going from order to disorder. God created order in Genesis chapter 1 and 2, but that energy that's usable, is dwindling all the time. And we know that the second law of thermodynamics is consistent with that, and the Bible is consistent with the second law of thermodynamics. And we'll come back to that in a bit here. Then the fourth one is the law of cause and effect. Every effect must have a cause. The effect cannot be greater in size or in kind than the cause. Scientists know that's a true law of science. All these four laws of science are agreed upon by all scientists. I don't know of any scientists who would argue that these are not valid laws. They happen all the time. And so the book, the statements in the Bible are clearly consistent with that. You can't take the Bible and come up with the second law of thermodynamics or this first or what have you, but you can see that the statements made in the Bible are consistent with these four laws of science that all scientists agree upon. Well, what about the laws of nature further? Everything in the universe is bound by laws. Physics, chemistry, mathematics, life, logic. Every place in the universe, the law of gravity is the same as it is here on Earth. All laws, chemistry, the elements that you have in the world here, they're all the same throughout the universe. Nobody has identified anything that doesn't fit into these categories. There have been some short-lived elements identified that can be produced with high energy, but then they decay and go out of existence very quickly as well. But there's no other elements in other parts of the universe that we don't have here on Earth. So we can explain the logical orderly state of the universe. That's possible to do because of these laws. And the consequence of laws of nature, well, laws require a lawgiver. The laws of nature are consistent with creation, and the laws of nature actually make science possible. Even atheists use these laws created by God to do science. If these laws weren't fixed, like Jeremiah says, we couldn't even do science. So when people say, well, creationists can't be scientists, well, I would say, how can atheists be scientists without taking the biblical laws, the laws created by God, into consideration? They have to use those laws, created by God, to do science, else they couldn't do science. So they're cheating in a way. They're using our laws and then trying to come up with evolutional explanations, etc. Laws of logic. We can use that. We were created in God's image, as it says in the book of Genesis. And these truths are universal. Everything depends on the laws of nature. We can't have, the law of contradiction is always true. And that is, you can't have both A and not A at the same time and in the same relationship be true. They both can't be true at the same time. You can say, your wife is in the auditorium, okay? And in fact, she is in the auditorium. And then somebody else can say, your wife is not in the auditorium. Well, that could also be true, but it can't be true at the same time. Okay, if she left to go somewhere and in a minute, then she wouldn't be here. So it has to be at the same time and the same relationship. God cannot contradict himself. So we can use reason to argue for certain positions. God is logical. We reflect God's nature because we were created in God's image. There is no way that an atheist can account for these laws. How did they come into existence? How did they evolve from an inanimate material, and then all of a sudden you come up with these laws of nature? How does that work? It doesn't. So the first two laws of thermodynamics are constant, as we saw. The total energy of any system remains the same. That's the first law. Second law, entropy of a system increases over time. That is, the useful energy available is reduced. Other constant laws includes the law of gravity. If I take a step off of the podium here, which way am I going? I'm going down. I'm not going up. It's always true. That is what a law is. A physical law is always true. Conservation of momentum, conservation of electric charge, those are constants that are always true. How did natural laws evolve? Did they evolve? We have no evidence that they do or did or are doing that today. There's no evidence. Laws of nature are uniform throughout the whole universe, the whole cosmos. So we can depend on those laws. A little bit more on the second law of thermodynamics, because this is very important in showing our origins. The second law of thermodynamics talks about increased entropy. That is, the unavailable energy increases over time. The amount of disorder in any place increases over time. Your bedroom gets more disorganized, disoriented, and dirtier over time, whether you're there or not. Everything goes through to disorder. Systems left to themselves. However, evolution, what does it require? Well, if you believe in evolution, and you look at that figure in the middle, if the Big Bang is how we came here, we started with chaos in a Big Bang, and so it started from nothing, and then, of course, nothing exploded, and here we are. Well, what does that require? That requires, if an explosion, it's chaos, so it's disorder. It has to go from disorder to the order we see today. We obviously have order in the universe. We can look at a orderly planet, an orderly solar system, an orderly galaxy, and an orderly universe. There's some order in there. So everything came from chaos and went to order if evolution were true. And so everything has to go from simple to complex. If everything started from the same living cell, that's simple. And you see human beings today, very complex. That's evolution. We don't believe that can, that is not consistent with the second law of thermodynamics. So what do we observe in nature? Well, we see things going from order to disorder, deterioration, less available energy over time, and increased randomness over time. Well, then apply that to living material. People would say, well, we have the earth, we have things on the earth, we have plants on the earth, and then we have a source of energy, which is the sun. That's all we need. We just need something to bring energy to this whole process. However, if there's no living material on earth and you have the sun shining there, and it shines on a piece of iron, let's say, it doesn't change that into some living material. It actually rusts that iron, and there's less energy involved there. So what you need in living systems, you need certainly an open system. You need a source of energy, which can be the sun. But if the sun is works on a plant, say, it has to go through some process of storing that energy and converting that energy into something it can use, and there needs to be some program involved in turning the seed into a plant, for example. There has to be some program. When you apply energy to that seed and you transform it into some storage mechanism, and you need a program, which is information, to turn that into a plant. And that's how photosynthesis works. So who put that program in the plant? How did that happen? You turn a seed into a plant, animal metabolism, energy, and that, your diet, the digestion system. There's the program. To take that energy, to store it, and to transform it into something useful. So again, there are 4 things involved: an open system, energy supply, a mechanism for storing and converting, and then a program to direct growth in an organized complexity. Looking at Christianity, modern science, and modern science is based on the work of scientists in the last 300 years, 400 years. Most of the disciplines of science have been founded by Bible-believing scientists. Not by atheists, but by Bible-believing scientists. And the greatest of all probably is Isaac Newton. And Isaac Newton, came up with the laws, these 3 I show here, the first, second, and third law. Law of inertia, second law of force equal matter times acceleration, and then the third law, equal and opposites. And so he was a very brilliant scientist. But what people don't know is that he wrote more books as commentary on the books of the Bible than he did on science. And yet he's regarded as one of the most brilliant scientists of the last few hundred years. Kepler, another Christian scientist: the chief aim of all investigation of the external world should be to discover the rational order that has been imposed on it by God. In other words, he was thinking God's thoughts after him. He recognized that God created the world that we live in, and he, as a scientist, was trying to figure out how he did that, what he did, and discover the laws that govern that. And so that's the true scientist, looking at how God discovered it, or how God created it. It's not trying to come up with another mechanism that didn't involve God. They took God as the foundation. They took the Bible as God's word and looked for that as references. There are many examples of scientists, even in the 1800s, who discovered things, scientific laws, by studying the Bible. The hydrological cycle, for example, in Ecclesiastic chapter 1, verses 6 and 7. That was discovered by Matthew Morey, who was an oceanographer. He founded the whole science of oceanography. And he did that because he read in those verses, there are paths in the sea and paths in the atmosphere. And he found them. And there's many examples of that, other examples as well. Okay, I want to just make sure we understand probability, because I'm going to use probability to show that certain things just cannot happen by chance, because they're mathematically impossible. And you've all dealt with coins where you flip and see how many heads you get in a row, or tails, or what have you. And getting even 2 or 3 heads in a row is not going to happen very often. Imagine if you're trying to put 10 heads in there, flip a coin randomly and get 10 heads in a row. The chance of doing that is only 1 in 1,000. You'd have to make 1,000 coin flips to get, one time 10 coins show heads in a row. And then 100 heads in a row, 1,000 heads in a row. I mean, those are not big numbers. 1,000 is not a big number. But now you're getting to 1 in 10 to the power of 300. That's a very small number, a very low probability of happening. It just, mathematicians say it can't ever happen, because anything less than 1 in 10 to the power of 50 just is impossible. It just won't happen. Mathematically impossible. Okay, so these are the mathematical probability laws that the scientists use to tell whether something is possible at all. Okay, and I'll come back to that. Now, the another big thing here is the anthropic principle. The anthropic principle states that the universe appears to be carefully designed for the well-being of mankind. In other words, the constants that we see on Earth and the constants we see in the design of the universe are such precise values that if they had been anything different, life couldn't exist, let alone life of a man. A human being couldn't exist. And that's what it all is all about. And if it were just just a few physical constants which had to be precise for life to exist, well, I say, well, that's going to happen. But here, we're looking at hundreds of physical constants which have to be exactly correct in order to support life. And I'm going to show you a few very important ones at the basic level, and that is the mass of the proton, the gravitational force, and the strength of electrical charges. And we also want to look at a total solar eclipse. How is this possible? It doesn't happen very often, but yet it is possible. What makes that possible, and why is that important? There are more than 100 precise universal constants, and there are many more than 100 that scientists know about today. We're going to also look at the role of the two gaseous planets, Saturn and Jupiter. So first of all, the mass of a proton. Mass of the proton is chosen for stability. And in case you forgot, that's how the what an atom looks like, with the neutrons and protons in the nucleus, and then the electrons spinning around it. So the mass of the free neutron is slightly heavier than that of a proton, and it decays to a proton, electron, and an antineutrino within a half-life of 12 minutes. Free neutrons cannot persist in nature. So you're not going to have just neutrons flying around. They just don't exist. If the mass of a proton were increased by just 0.2%, it would decay into a neutron, positron, and a neutrino. This decay does not occur in nature. If it did, hydrogen could not exist. Hydrogen is the dominant element of the universe. Without hydrogen, the universe just could not exist. So again, it shows that the weight of a proton, the weight of a neutron, the weight of an electron are such precise values that they can support the existence of hydrogen and other gases and other elements, and then that they in turn can support life. Gravitational force. As you might remember from school, it is inversely proportional to the square of the separation between the separation distance between the two masses. This fundamental force holds the universe together, controlling the orbits of all members of our planetary system. That's why our planets can orbit the sun and not just fly away, because the force of gravity, and it is such precisely set at a value of 2.000 that the universe hangs together. If it had been 199 or 2.01, we wouldn't be here to talk about it, because the universe couldn't exist without that value. So again, another evidence of design involved there. The third one, the strength of electrical charges, measured in Coulomb force. It varies, again, the same as gravity, as the inverse square of the distance between the charges. And since the electrical force is much stronger than the gravitational force, it's been measured to an accuracy of 16 decimal places to be 2.0000. If it had been a little less or a little greater, again, it wouldn't work. It has to be exactly 2.00. Reflects God's purposeful planning. Now we come to the solar eclipse. And the total solar eclipse is one that is where the sun completely is obscured by the moon. We know the distance from the Earth to the sun, 93 million miles or so. We know the distance from the Earth to the moon, and it turns out that the ratio of that is 1 to 400. The distance to the moon, just 1/400th of what it is to the sun. Well, it turns out that the sun's diameter is also 400 times the moon's diameter. So it is exactly the same ratio. The moon is exactly in the right orbit, so that you can periodically get this total eclipse. And by doing that, when that happens, scientists have discovered certain aspect of Einstein's laws to be accurate. They could measure it because of the eclipse. If the eclipse didn't occur like this, like a total eclipse, they couldn't have measured some of these constants that Einstein came up with. And so, again, it shows the purpose in the design. You may wonder why you get this, every so often. Well, it's designed to do that for a purpose. And I'm sure you've seen pictures like this. Okay, and then we come to universal fine-tuned parameters. The numbers I've given here, universal fine-tuned parameters, 35, I think there's more now that scientists have discovered. It depends how you name them. Numerical constants and equations for gravity, electromagnetism, strong and weak nuclear forces, all four forces. The constants are known, and there are exactly the values they need to be for the universe to hang together. The ratio of the proton to the electron mass is exactly what it needs to be, as we saw in previous slide there. For our galaxy, the solar system, the Earth, there are more than 66 parameters that scientists know about. It's such as the distance from the sun is just right, to support life on Earth. We are actually fairly comfortable. We may complain about the weather. We don't like the weather today. Well, if you were a little further from the sun, you would like it much less. In fact, you may not be able to even survive further from the sun. So the distance from the sun is important. The size is important. The temperature and the type of sun is also very important. We are at a maybe called a Goldilocks distance. We can be fair. We can make ourselves comfortable on the Earth. We can put extra clothes on if it's too cold. We can take a few clothes off if it's too hot. But we can be comfortable. We can live. We can even live at the North Pole and South Pole, as cold as it gets there, by using clothes or other means. The other things is the actual tilt of the Earth is exactly what it needs to be in order to support the four seasons. The rotation speed of the Earth, every 24 hours it goes around. Now, if it went faster than that, every 12 hours, what would happen? Well, it would be too hot on the Earth to support life. And if it were too slow, in other words, took 48 hours to go around, on the backside of the Earth, it would be too cold, and life couldn't exist. So the speed of the rotation is also one of those constants that is very important. I'm going to show you an exoplanet that scientists claim to have found now that is about twice the size of the Earth and about 8 times the weight of the Earth. But the problem is it's too close to its star. It is about 2,000 degrees centigrade. So a year on that planet is 18 hours. 18 hours. Imagine how old you could be on that planet. First of all, you have to survive the high temperature, but it obviously cannot support life the way we know it. So the rotation speed is important. The moon is important. The fact that the moon causes tides, because the tides lift the ocean up and cause waves in the ocean, and it keeps the ocean clean. Without those tides, we'd live in a very stagnant environment, and we couldn't remain our health in that kind of environment. Composition of the Earth. You wonder, there's more than 90 elements that make up the Earth that they find, and somehow the ratios just seem to be right. Gold, for example, we don't have a whole lot of that. It's a very desired metal, and then there's silver, which is about 20 times more prevalent than gold in the Earth. And we use more silver than we use gold, because silver has a lot of uses. Carbon, for example, is a high proportion of the Earth, and we use that as fossil fuels. And so all those proportions seem to be right to support man. Stability of Saturn and Jupiter. They're out there. They're gaseous planets way out there, way beyond the Earth. What do they do for us? What use? Well, they shield us from radiation. Saturn and Jupiter are very huge planets, and so their mass is much higher than the Earth. So the gravitational pull of things that come close to it draw those things into Saturn and Jupiter and keep them from hitting the Earth. So they protect us, protect life on Earth. Okay, a few other things that I hadn't mentioned yet, the strong magnetic field to deflect harmful radiation. So even the magnetic field in the Earth deflects dangerous radiation that could harm us. It's tilted at 23.5 degrees for optimal seasons, the 4 seasons that we have. 70% of the Earth is covered with water. Turns out that water is very necessary for life, at least life as we know it. And when scientists look at other planets looking for life, they're very excited when they find that there's some evidence that water was on that planet. Well, nothing close to what is on Earth has been found. 70% of our surface is water. There's nothing else that is anywhere close to that. Water is essential for all known life, and water has some very special properties. The fact that water, when it freezes, the ice doesn't go to the bottom of the lake. It comes to the top. It floats up. Imagine if it went to the bottom. What a mess we would have. What good would that do us? Okay. Atmospheric pressure is just right to support life. Earth contains many diverse living organisms. And there's also that protective zone, the ozone around the Earth. Moon is at the right distance to induce tides. I mean, if the moon had been closer to the Earth, you'd have huge tides going up and down, hundreds of feet possibly. We don't have that. We have maybe 20, 30 feet at most in most places, and that's what we need to keep the oceans and the lakes clean. So they're at the right distance to support that. And this is just a slide showing the Earth's axial tilt. The fact that it is 23.5 degrees tilt from the North Pole, both at the North Pole and the South Pole. That is what gives us the 4 seasons that we enjoy having, at least in most parts of the world. Okay, so some other critical Earth constants. 122 very narrowly defined constants identified. Oxygen level for life is optimum at 21%. Earth's position in the solar system obviously is exactly where it needs to be to support life. The magnetic field we talk about keeps dangerous radiation away mostly. The thickness of the Earth's crust controls the release of oxygen. We do need the oxygen to live. The Earth's size is ideal for where we live. The rotation is just right to support life. The tilt is right to support seasons. And the rotation of the rate of the Earth controls the temperature differences, as I discussed a few minutes ago. So again, the tilt is just right. If you look at, and obviously I haven't listed all 122 here, but if you look at the probability that all of these 122 physical constants are exactly what they need to be to support life, you get a number like 1 chance in 10 to the power of 138. Now, is that mathematically possible? Randomly? No, can't happen randomly. Somebody designed those parameters to be exactly what they need to be. Can't happen by chance. Remember, anything less than 1 in 10 to the power of 50 is mathematically impossible. All scientists will agree. And the number 122, I mean, it's too small today. Scientists have discovered more physical constants that are exactly what they need to be to support life. Life cannot exist without those being exactly what they need to be. Jupiter and Saturn, they do have regular orbits. All the planets around the sun have regular orbits. They're pretty spherical, although most of them are somewhat elliptical. But if you look at some other planets that they found, you'll find that they are much more elliptical or parabolic. They go way out and then come way in close to their host star. And that, of course, you can't support life because there's too much variation over time. In the case of the Earth, yes, it is elliptical, but the variation isn't that great that we can't live in those temperatures. Jupiter gravity force is very strong, and it protects the Earth from comets out there. And so comets going towards Earth will be captured by Jupiter more likely than not. And in some cases, it actually throws comets out of the solar system. So they are there for a purpose. Jupiter acts as a comet and asteroid magnet, shielding Earth from catastrophic collisions. The other thing I want to point out, you can see it in the figure there, the Milky Way system on the bottom right. There's the sun, and that sun is located halfway between two arms of that spiral galaxy. And so there isn't as much space stuff as you might imagine in the arms themselves. So it's more in the clear. And that is a very important thing because that allows us to see much more of the universe than we could otherwise see if we were in the middle of one of those arms. And the fact that we are located there means that we can observe much of the universe than if we weren't in that kind of position. And so that's one of the benefits of the planet that we live in. Okay, and then I want to talk a little bit about the search for exoplanets. And exoplanets are also called extrasolar planets. In other words, these are planets which may be outside are outside of our solar system. You know, we know the 8 ones that exist within our solar system, and there's been a story in the press about Planet X, which might be out there, way out there in our solar system, although they haven't verified that yet. But nevertheless, here scientists are starting to look for planets that are on other star systems within our galaxy and outside of our galaxy on other galaxies. And the instrumentation needed for that has to be very, very precise. So this work really didn't start to about 1995 before they could really look for these extrasolar planets. So again, it requires a star, and most scientists are looking for planets that are what they call Earth-like. In other words, they'd like to find some intelligent beings on another planet in another solar system and even in another galaxy. Okay, I guess they haven't found enough intelligence on Earth. They're looking outside for more intelligence. So it's hard to do because most planets cannot be observed directly. I mean, you can't use a telescope to find those planets. Those telescopes are not strong enough. So how do they discover some of these? First, by means of wobbles. What do I mean by a wobble? Well, as the planet goes around a sun, because of gravity, it pulls on the sun a bit, and so there's a slight movement in the sun, the host sun of that planet. And so astronomers can detect that now and measure it. So they can't see the planet directly, but they're saying it must be a planet because something is pulling on that sun. In a lot of cases, they haven't verified it, but they think there might be a planet there. Now there's some more powerful techniques. They can use what they call the transit method. Planets, obviously, they pass in front of their host star as they go around their host star. And so when it comes in front of the host star and the telescope can see the reflected light from the host star, there's a intensity change in what they see. So a very slight dip in light intensity, they detect that and surmise that there must be a planet doing that. So it requires large telescopes, high precision instruments, and some very sophisticated software. What's the probability of some of this? How probable is it that they can find another planet with the same parameters as Earth or something very close that could support life? Well, various calculations have been done. If you only have 80 fine-tuned parameters, the probability of finding another planet with those parameters exactly the same and therefore able to support life would be 1 in 10 to the 53rd power. Well, again, even that is mathematically impossible. But if you look at 128, and we have many more than 128 today, the probability becomes even less, 1 in 10 to the power of 166. So how many planets could we discover that way? Well, if you make some assumptions. Remember, I showed that there's about 10 to the power of 11 galaxies out there, and each galaxy has about 10 to the 11th stars per galaxy. So you multiply those two together and you get 10 to the power of 22 to the upper limit of the number of stars in the universe. Well, how many of those stars are likely to have planets? Even if we don't know, but if the scientists assume one planet per star, then there could be 10 to the 22 planets in the universe. Sounds like a large number. Certainly one of those could support life, you would think. Well, if you multiply that out, taking those 80 fine-tuned parameters or 128, let's take the 128 because we know there are more than 128 fine-tuned parameters. Multiply that 10 to the minus 166 times 10 to the 22, you're still left with only 1 in 10 to the power of 144 planets that could support life. That's a probability. That is beyond possible mathematically. It just can't happen. So scientists know that you cannot, the probability of finding another planet with life on it is 0, really, because it's mathematically impossible. Current planet search results, and they started in 1996, 1995. More than 1,000 planets have been discovered. And many, well, I shouldn't say many, but some of these are Earth-like. And it turns out that only 5% of stars have planets, not the one planet per star, but 5% of the stars don't even have, or 95% of the stars don't have any planets at all to even consider. The planets are either too large that they do find, or too close to their star, or with too erratic an orbit to harbor life. Have their probabilities changed over these last 20 years? Yep, the probabilities have gotten smaller, less and less. Less and less probability of finding life on another planet. And you can't see this picture here, but it shows a similar sun to that of our solar system, and it shows a planet like Jupiter, a gaseous planet. Most of the planets they find are gaseous, not terrestrial planets like we would require for like Earth, that is required to support life. And there's a galaxy that they found that has something that looks like this, but again, they haven't verified the characteristics or the constants of that planet. Here's the one that they're talking about, an Earth-like planet. There's a story in the paper actually just last month. A news story recently reported that the first detection of an atmosphere around a super-Earth extrasolar planet, and they named it 55 Canry E. Canry is the galaxy, and E stands for Earth. It's an Earth-like planet. By evolutionary reckoning, this primitive atmosphere should have disappeared. Its presence may be evidence that the creation is actually young, just as indicated in Scripture. And this particular galaxy is about 40 light years away from the Earth. So you can imagine scientists are not going to be able to go there and take measurements. It's all very indirect measurements. So they don't have good data. This drawing here, this is not a picture from a telescope. This is an artist rendition, we have to remember. It's what they think they saw, but they couldn't see it directly. It's what the artist came up with. And here are some comments that made even by evolutionists, secular scientists say, George Greenstein says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or capital agency, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Was it God who stepped in and so providentially crafted the cosmos for our benefit? It's the right question. How surprising it is that the laws of nature and the initial conditions of the universe should allow for the existence of beings who could observe it. Life as we know it would be impossible if any one of the several physical quantities had slightly different values. Here's a Nobel laureate, Steven Weinberg, who I'm sure you've heard of, making that statement. There's just no way life could be supported if some of these physical constants had been different from what they are on our Earth. And as far as I know, he's not a believer, wasn't a believer, but secular scientists have to admit they just don't understand how this could be without somebody monkeying with the physics, as Fred Hoyle says here. Common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Fred Hoyle, a secular astronomer. So what does evolution have to say about this? Well, evolution is unable to deal with such permanent properties of nature. It can't explain. I mean, how could evolution possibly have created these laws in the first place? How could it change from this explosion at the beginning of nothing and come up with these permanent properties of nature, which are physically the same throughout the whole universe? How do you explain that from a secular point of view? You can't. Max Planck, a Nobel Prize winner, has this to say: according to everything taught by the exact scientists about the immense realm of nature, a certain order prevails, one independent of the human mind. This order can be formulated in terms of purposeful activity. There is evidence of an intelligent order of the universe to which both man and nature are subservient. And I think he states that correctly, a Nobel Prize winner. So, in conclusion then, Earth is our privileged planet. The anthropic principle, which we talked about here, we talked about the 100-plus unique physical constants. Well, there's many more than 100 right now. I'm going to have to update that. The privileged planet, the video that some of you may have seen, and I think it's available on the back too for those that are interested, Gonzalez and Richards explain in the book there that Earth is uniquely situated to sustain complex life. All the parameters are exactly what they need to be to support life, not just in the Earth, but also in our solar system, in our galaxy. All those constants are exactly what they need to be. And what we didn't talk about here much was that the Earth is also uniquely situated to observe the universe. And Richards and Gonzalez explain that very well in the book. So despite what the secular scientists say, they tried to explain the anthropic principle by saying, we are just one of many universes. We just happen to be lucky. We get all the parameters right to support life. But there may be other universes, or maybe even just one, that also has their parameters close enough to right that it could support life. The problem is we can't see those universes. We can't even measure it, can't detect it in any way. And as Anthony Flew, who was a well-known British atheist, and wrote on that for 50 years, he finally came to the conclusion when he reached 80s. He wrote a book named There Is No God. And in the 80s, just about 10 years ago, he wrote a new book, There Is a God. And he came to that conclusion because he said the multiverse, whether it be or not, we still have to come to terms with the origin of the laws of nature, and the only viable explanation here is the divine mind. There's no other explanation. Physics, the laws of nature cannot be explained any other way. Somebody created those laws so precisely that it can support life and it can support the earth. So in conclusion then, the earth was designed for us. I've got that quote up there from Isaiah 45:18, who formed the earth and made it. He established it. He did not create it empty. He formed it to be inhabited. And then I also make some quotes from John Lennox, who was an Oxford mathematician and a very articulate Christian, and he articulates our faith very well from a mathematical and science point of view. And he's written many books on that, given a lot of talks, has even debated Richard Dawkins, who's also a professor at Oxford University, same university, but a biologist, and of course has totally different belief. And I think John Lennox has much stronger arguments than Richard Dawkins has for what we believe to be true. So with that, I want to thank you for your time, and I think we'll probably take a few questions here.
Okay. Before we open up for questions, we need to take up a quick offering. Again, the offerings that we take up on these evenings are earmarked for this specific program and used to pay our speaker honorariums. A lot of our speakers come in from out of town, so we got to cover a little bit of travel and give them an honorarium for speaking. So help us out if you can. We make out any checks that you need to Cedar Park Church. All this money is turned over to them, and then we make a check request to pay our honorariums and stuff. Let me just send us up a word for the offering. Father, Father, again, we thank you for that we have people like Heinz that are so knowledgeable in the areas of science to help us understand how science should be interpreted from the biblical worldview. We ask for your blessings upon him and his ministry, Father. We also ask for your blessings for Cedar Park, for churches like this that are so involved in education. We ask your blessings for Cedar Park Christian schools and the various campuses that are around the area, Father, and just ask that you allow this ministry to grow and for its doors to be open to people. And Father, we lift up this church in particular and the pastors, Father, and ask for your blessing upon them, that you will help guide them and give them wisdom to help with the leadership in this ministry, Father. We just lift up Cedar Park to you, Father, and we'd ask for your blessings for the offering that's taken up this evening, that these monies will be used to further your kingdom. In Christ's name we ask these, amen. All right, so we got a time for a few questions. We can't take many, but we want to give you an opportunity to ask questions of Heinz. If you have any about the remarkable design that we see out there in the cosmos, just raise up your hand and I'll bring the mic back if you have a question for Heinz. Any questions? I got one for you, Heinz. You know, I always look at everything and having a purpose, and I've used some of the exact same arguments that you had up here, and especially like a Jupiter. You mentioned that Jupiter and Saturn were these massive bodies out there, and that one of the arguments I heard is that they stabilize the actual position of the Earth within the solar system, but as well that they protect the Earth from these cosmic bombardments like comets and things. So that then kind of begs the question: well, why are there comets out there? You know what I mean?
Yeah.
I mean, I've always kind of wondered that. You know, we have this huge asteroid belt between Mars and Jupiter, and it seems to be a hazard zone. These asteroids periodically coming in and crashing into the Earth. And any thoughts about why we have asteroids out there that's seemingly dangerous? There has to be a purpose for them as well. We may not understand all of the physics of the solar system, but
I'm not sure any science has a good explanation for all that.
I mean, just from an intelligent design perspective, can we think of why there would be comets? Or, I don't know. That's just I've always
because we don't need them to support life on Earth.
You would think. But there's probably a lot of things we don't understand that we need, or that are necessary by physics. Another one would be planets. I mean, to tell you the truth, before they discovered these extra solar planets, I would have assumed that they would not discover them. You know, I understand why there are planets in our solar system to protect, for all of these reasons that we need them for the Earth, but must be necessary to stabilize stars in general. I mean, the fact that we find planets out there in other stars means that there has to be a purpose for planets around these other stars, don't you think?
Yeah.
I don't know.
Yeah, you think so, but you're asking me a question, the mind of God, right?
I know, right? Yeah.
We'll find out when we get there. But science may find some purpose for some of these.
Yeah.
Like Saturn and Jupiter. We know they have a purpose. They didn't seem to have a purpose initially, but scientists have discovered that there is a reason.
We'll always find a purpose for everything.
Yeah.
We look into it.
Yeah. And it's it's all created for God's glory, and we may not understand. We don't understand all that.
Remarkable design out there.
Yeah.
Well, let's go. So now you have a question.
This is a difficult question, but the precision of physics is so strong for precise design. This implies a designer for physics. I might make a comment on that, or perhaps more carefully. Why on earth are physicists, as well as the ordinary mortal scientists, proposing multiverses? Seems to me that that's another catch on the word, an infinite universe. The fact is we can't explain where this one came from. Well, we'll just make a multiverse.
Yeah. Well, that's exactly. I mean, Stephen Hawking is a big proponent of that, as you know, in the grand design. I mean, he comes with this idea. Because they can't explain why all the constants are exactly what they need to be to support life on Earth. Well, maybe we just got lucky, and there's another universe out there that we can't see. So it takes the monkey off their back in a way. That's all, because it's not a scientific explanation at all. There's just no way they can do that.
Yeah, so I was just trying to understand the purpose behind talking about the probability of having another planet that supports life. I mean, I think the whole point of tonight was that it's done by design. So if it's done by design, it's not a probability thing, and that math doesn't really apply, right? It just depends on what an intelligent designer wanted to do. If he wanted to create, multitudes of planets that were special to him, he could do that. So I'm just kind of curious about what was it just to kind of emphasize? I mean, I think it was just to emphasize how improbable this planet is to be just by chance.
Yeah, that's the basic argument. Remember, every concept can be explained by one of three ways. Either, it's just a random thing, we just happen to get lucky, or it's a physical law that requires it to happen that way, or it's by design, somebody designed it. And clearly there's so much information in our universe and on the Earth and about us, living cells and all that. It just can't happen by chance. It's mathematically impossible. Much, much less than 1 in 10 to the power of 50. And so somebody designed it.
Climate change is a big argument in the political world. Is it true that man can change climate by burning carbon, and that the poles would melt and flood all of the covered Earth?
Well, you just happen to hit one of my other hot buttons. I have written a analysis of that topic of global warming, anthropic global warming. Is man the cause of global warming? And they don't ask the question, well, what about some natural causes? Are there natural causes? And I would submit that the amount of carbon dioxide in the atmosphere is so small, 0.04% of all the possible greenhouse gases. No matter what you do, you can't control it. I mean, we can't even predict the weather a few days out. How can we predict the climate, decades or centuries out? We can't. I believe there are feedback systems built into the Earth that control our climate very well. All you have to do is go back to the medieval period when it was much warmer than it is today. And, man wasn't driving cars back then. And guess what? Greenland was green. And man did very well. In fact, the more carbon dioxide there is in the air, the better growth we have of our green stuff. So more carbon dioxide is actually good for us. Now, the carbon pollution is bad for us, and we need to control that. And man has done that in many cases. And then the reason we're warming now is because we're coming out of a little ice age, in the 1700s. The Thames River in London was frozen over. And even for those of you who remember 30, 40 years ago, well, we complained about global cooling. If we don't do something about global cooling, we're toast. We're not going to survive. And in fact, if you look at the facts of some of the politicians, John Holdren, who is Obama's science advisor, he is very adamant that if we don't do something about global warming, we have to do it this year, because otherwise we're goners. Earth can't survive. That same John Holden in the 1970s, what did he say? Hey, it's getting cold here, and it's getting colder. And if we don't do something about this climate now, we're not going to make it. Same thing. I mean, it's all politics. There's no science behind it. And if you look at my website, in fact, if you go back to my website, you can see I've got a paper there on analysis of global warming. And it's just politics. It's not science. So anyway, a little off topic, but you hit one of my hot buttons.
Okay, we can take one more question, and then we're going to close it down. One more question.
I have a question about, you mentioned the radiation from the sun. And I heard that for man to protect himself from that radiation, like if they were to go to the moon, leave the atmosphere like over 500 miles above the Earth, that they couldn't build a spacecraft thick enough to protect them to go to the moon. What is the truth about that, about radiation in space?
Well, I don't know the numbers for that, but obviously men have been to the moon, and they haven't been radiated to death. Being a nuclear physicist, I worked in a nuclear reactor. We wore protective gear if we got too close to the radiation source, and we had Geiger counters that could measure the radiation, but we were never really in any danger. And I don't think in space, you're all of a sudden going to get hit by all this radiation. But again, I don't know what the numbers are, like from between the Earth and the Moon. But I doubt if they're deadly, because obviously many astronauts have gone up and down and done, survived that just fine.
All right, thanks, Heinz. You guys, give me a little bit.